Oh, we're live.
Oh, we're live? How we doing?
Weasel.
PreCal students and my YouTube followers, all three of you. Welcome. Thank you, Maddie. Welcome to Coach Jay's class. I've got a little inception going on. If you look at right in the background, yes, there's like 10 of me. And as I come straight across, so welcome. We're talking today about exponential functions. We're talking about money. It's always a good thing. Compound interest, so we're going to touch base on that in just a minute, okay? As we begin, what I'll do is I'm going to actually start right here so that everyone can see here. Let's pretend that I've got money, right? And can someone tell me how exponential equations impact money?
Investments.
How so?
It grows each year.
Okay, yeah. So what do we call that? When it grows, what do we call that growth?
Exponential growth.
Yeah, exponential. That's true. Exponential growth. That's true. But how does it grow? How does it grow in that? If I put, let's say I have this money right here. Okay. All right. This was from my extra job. So let's do this. Let's say I've got this right here. Okay. All right, right there. I've got that. And let's say that I take this money and I give it to Bailey. Okay. And I say, all right, Bailey. That's my Sarah's Donut budget right there for the month. And as I give it, I don't know if I trust you with that. Let me do this. Let's give this right here. That's a little bit better. $1, probably better than that one. All right. So as I give that to her, what ends up happening is I give that money in a bank, right? And as it sits there, what happens to it? Does it just sit there? Yeah, it grows through what?
Interest.
Through interest. So we have a couple types of interest. What's one type of interest? You remember?
Compound interest.
Compound interest. Yeah, that's really good. What makes compound interest so powerful? All right, let's do this. All right,
You get more money.
I'm going to give someone who I trust, Aiden, the money, the large money, okay? So all of a sudden, I give Aiden some sort of money. When it sits there after year one, let's say I have interest that's added on. What happens the next year? I take interest on top of the total, right? Yep. All right, so that's what's powerful about it. What's the difference between that and simple interest? Yeah, simple interest is just simple, right? So if I put $10,000 in a bank, right, that interest is going to be the same from year to year, whereas compound interest builds on top of itself, okay? And so when we end up getting to the project come tomorrow, you'll end up seeing that a little bit more when you get to that business, when you get a business partner and you start working on business proposals and that sort of thing. We go through the logistics, that's what we're looking at there. So that's where the basis is behind that exponential growth and exponential equations there, right? Where's another place that exponential equations are used? Exponential growth or decay? Can you think of one? You just did one if you tweeted. How so?
Twitter.
Yeah, how could Twitter be used as exponential growth? You know?
I retweeted your tweet and all of my followers see it, and then they see it and they can possibly retweet it.
Bingo. Bingo. So the power is that with Twitter, here's an example. How many of you watched the Oscars? Okay. How many of you watched the red carpet of the Oscars? All right. All right. So did you all see, and again, I don't know the movie. I don't even remember the actress, but all I remember was she brought her mom over there to the Oscars, and they were interviewing her and her mom, and there was something going on. There was contention though. That's all I remember was there's contention between the daughter and the mom. It was very entertaining. But as the contention went, all of a sudden it was like in 5 minutes, like that was the thing that was trending on the Oscars. It was like, like whatever hashtag they had or whatever. And literally that's what was trending. And so I just thought about it, man, how quick it can happen. When someone tweets something, it goes to their friends, they could retweet it. And then all of a sudden with exponential growth, that's what happens. Now, when you end up seeing, for instance, the mogul's brain, right? Jordan's brain, why is it so impactful? I would argue that it's not the brain. It's not even necessarily the clothing, right? Because when you think of Nike, it's not necessarily that, but it's all of word of mouth. And what Jordan has done a good job of, and Mogul's brain has done a good job of, is they have a lot of ends. GAC, Buford, you could go Gainesville, I think they have, Parkview, and they have all these schools that are finally buying in. And when you tweet something, it's helping their brand out. And so again, just kind of a basis behind it, what exponential we're talking about. All right, so with that being said, let's go in to our notes. We're going to start this screen share. There we go. Again, we'll take out our notes real quick. Again, remember an exponential equation is something that is rising, right? So exponential growth increases to the right, where exponential decay decreases to the right, all right? So real quick, we're not going to go over all the logistics here, but just so that we have an idea, what is the domain of just an exponential? Well, first of all, we know exponential is y equals like 2 to the x, right? That's exponential. So what would be the domain of an exponential in this case? Bingo, I'd take either. All real numbers or negative infinity to infinity. A little shout out to Tyler and Aiden. Nicely done, okay? All right? Follow them on Twitter. A little shout out. Never mind, for just one. So Facebook, or come and watch Aiden wrestle or something, all right? So next one, range. What's the range?
Range is 0 to
Good, 0 to infinity. Nicely done. Okay, so you kind of put that in there. What would be the, is it increasing or is it decreasing?
Increasing.
Yeah, it's increasing from left to right. Okay, so what would that end up being with the increasing? What would you say it's increasing from?
Negative infinity to infinity.
Yeah, because it's going to keep going to the right. Okay, very good. So we could say all real numbers for increasing, or negative infinity to positive infinity. Is it decreasing? Obviously not. You put none. Okay, so we're just touching base on this. I know we're just going flying through. Just fasten your seatbelt. Again, we're doing this for tomorrow. Okay. Last thing, asymptote. Okay, asymptote. What would that end up being in this example? What is it approaching?
0.
Y equals or x equals?
X equal, or y.
Y equals, good, because it is a horizontal. Nicely done. Okay, it's that horizontal at y equals 0. Are there questions on that? Excellent. All right, so we've done all of that. Now, intercept, we have one y-intercept. I can't see that one quite clearly there, but you know there is one there. And so I just want to make sure we touch base on that. All right, so we hit on the introduction. Let's go to a couple other things. Here's what I want you to do, okay? Those people that are at home, my Twitter followers, you could do this at home yourself. In 2 minutes, I want you to go through numbers 1 all the way down through 4, and I want you to give an example of how y equals, or f of x equals 3 to the x is transformed over the x-axis, y-axis, left and right, and shift up or down, all right? So I'm literally going to give you a minute or two. It begins right now. Go right ahead, okay? Real quick. Try to see if you could change that equation around with that type of transformation. Y'all see what I'm doing there? Okay? Yes, just 1 through 4. The 5 and 6, stretch and shrink, I'm not necessarily interested with right now. More of the other stuff right now, vertical or horizontal. The higher the base, the skinnier it'll get, right? That's kind of the stretch and shrink. But that I'm not really concerned with. Like, the higher this number is, the steeper it'll grow, right? So if like it's 10 to the x, that's going to be a lot higher than, it's going to increase a lot higher than 5 to the x. That's what we're talking about there. So these two, not so much. All right, did you get an example down for each? YouTube followers, are you following me? I hope so. Right now, there could be people all over the world watching this.
I bet.
Keyword could be.
I might say something, but I forget. I'm on YouTube right now. Yes, I'm on live YouTube right now. Hangout on air. This is a true story while you finish it up. I almost couldn't make it today because of the snow. And what I was going to do is I was going to actually do a live broadcast in. I thought that would have been kind of cool. Like,
You should have done that.
yeah, I was going to, but
Where do you live?
Cherokee County.
Which is, it was bad.
Yeah, very
Schools were
bad.
canceled up there.
Yeah, it was like my whole yard. I was just tons of snow.
Yeah, I would have been like, yeah, I can't make it. The
It's
roads
so
are
nice.
icy.
I wanted to see y'all's pretty faces.
Could have just FaceTimed us.
You're like, wow.
Aw.
All right, reflection over the x-axis. So real quick, we'll kind of use this here. Remember, a traditional graph would look something like this, right? Y equals 3 to the x. I know that that's not exactly accurate, but that's what the gist of it would look like. Now, if I reflected over the x-axis, how would that look there? What would the pic look like?
It would be y equals -3 to the x.
Exactly. Good. So the reflection over the x-axis would be f of x equals -3 to the x power. That's that negative on the outside flips it over across the x-axis. All right, y'all are awesome. We're gonna keep going. Reflection over the y-axis would do what? Yep, that's exactly right. So f of x equals 3 to the -x power. All right, shift left to right. What would we do for that one?
You had to add like a +1 or a -1.
Yeah, so with where would I add it?
After the 3 to the x.
Yeah, it actually would be, if it's left to right, it would be in parentheses, right?
Oh, in the parentheses of the exponent.
Yep, so what would that do with the x plus 1 in the exponent? Where would it move it?
You move it to the left one.
To the left, right? Right? To the left, now, kick, now, kick, now. Oh, that's right. Yeah. Walk it by yourself. All right, so what would be the vertical shift?
Y equals 3 to the x plus 1.
Yep, so on the outside, that is my vertical, whereas on the inside, that's left or right, okay? That make sense there? All right, so question. 3 to the x plus 1 on the outside, where would that asymptote be, 3 to the x plus 1? That, very good, y equals 1, right? So the vertical shift changes my asymptote by wherever it goes. If it's not, then it'll just be y equals 0, okay? Horizontal would just be left to right, but it doesn't change going up and down.
Your horizontal asymptote.
Bingo. Horizontal asymptote is right. Good. Nicely done. Remember, it creates a crack in the graph. Okay, that asymptote creates a crack in the graph. All right, next one. Can't believe I just said that. All right. Actually, let's go backwards here. Here's what I want to just quickly talk through on this, because, again, I think we've got that there. If I was to graph number 9, I want you to just kind of do it again, okay? 30 seconds. I want you to graph it. This time, I want you to graph it by hand, and then I want you to determine what are the intercepts and the asymptote, okay? So real quick, again, if I was creating an x and y chart here, what could I plug in for x?
0.
Okay, I could plug in 0. I could plug in 1, -1, right? So I want you to try to graph it real quick, about 20 seconds. Plug in those values, get them out, see if you could graph it, and then we'll go from there, right? Find the asymptotes as well as the y-intercept. Again, that's number 9, which is on your homework, as well as the sheet that I gave y'all.
Have to graph it. Or
Yeah.
you just plug it in or
Yeah, this one, it'll say do it by hand. It'll say do it by hand there. Correct. This is for 3.1. Yes, ma'am. Do we get out at 12? Is that right? Or is it 12:05?
Oh,
I have the schedule on my phone.
Yeah, go ahead. That's fine, Bill. Thank you.
so for everyone you have to is this for the vertical stretch or is it just something that we have to do with the x and y?
Yeah, all we're doing is just being able to graph it with accuracy here and knowing that, okay, when I plug in, right, because both of these are the same thing, right? 5 to the -x is the same as 1/5 to the x. So as I plug in, my big question is, all right, what would the graph look like? And then tell me what the asymptote is and then identify what the intercepts are.
So how many numbers is this plug in?
I would say whatever floats your boat, probably about 4 would be probably sufficient as long as it's spread out. As long as you get a good idea there.
12:05.
12:05. Excellent. Perfect time. All right. So as I plug in, and I'm going to kind of have a seat so we can kind of rock through this. If I plugged in -1, what'd you get out? 5. Very good. Thank you, Aiden. What if I plugged in 0? What would I get? Are you sure? I think it's 1, right? Anything to the 0 power would be uno, right? What would I plug in next?
1.
Yeah, 1 we get 1/5, right? Plug 2, you get 1/25, all right? So as I plug that in, right, I get different values. So I get -1/5, which would be about right in there, 0, 1, 1 1/5, and it obviously just keeps decreasing there. So as I move, I know that it goes and decreases from left to right, okay? What do we call that if it's decreasing from left to right?
Decay.
Exponential decay, very good. Have you, where's exponential decay applied? Exponential decay? And how many of you have seen the movie Contagion or I Am Legend?
I've seen I Am Legend.
Yeah, so like when they die off, right? So when people are dying off, literally that bacteria, you could say it grows, but when people are passing away because of that virus, you could almost say it's exponential decay there, all right? Yeah, I think it's pretty good.
I didn't think it was that good.
Yeah, it was
I forgot.
Pretty
so
cheap.
that's not been-
It was just wasn't very action packed. Just like a long movie.
sure. All right, so if you could just, again, as we wrap this up, okay, as we wrap it up, I know the temptation is to finish off. I know with 35 minutes, I know a lot of you would rather be home right now. I get that 100%. But let's finish off strong so tomorrow we can move forward on this and have very little time and more time for that project for tomorrow. Tell me, number 11, what type of transformation would occur?
You'd shift to the right 2.
Good. What about 13?
13, you would reflect
Over what axis?
over the y-axis.
Over the Y. Good. From
And
right
then
to
you
left and
move
left to right.
Down -3.
Good. It'd be, again, and you go down -3. What would be the horizontal asymptote of 13?
-3.
Y equals -3. Good. Is there anyone that's not getting that maybe needs a refresher? Are we good?
So you have to know the intercepts by like on this one where it's asking like identify any asymptotes and intercepts. So you understand the asymptotes by the 2 different shifts, correct?
Yeah, well, I would do that. The asymptote, right, by the 2 different shifts, you can kind of gauge it. The best way is to plug it into a T-chart and see. Now, since it only reflects, right, the y-intercept will be 0, 1. The only time it doesn't is, you're right, Tyler, when you have a horizontal or vertical shift. Good. Very good. Are we good to go? All right. As we wrap this up, I know that I've got like 1 minute, so I want to make sure I touch base on this before I go any further. Reminder, if I were to graph these with my calculator, I think that you could have enough kind of knowledge of this, be able to figure out that, okay, I plug it in and I go straight to what's the first thing I do when I graph it?
0.
Okay, well, if we do it by calculator, we don't have to plug values in. You could go to zoom what? Standard, okay? Then you could go to where? Zoom fit. Good, and then you could kind of zoom out or zoom in. The idea is that when you end up graphing this, okay, let's make sure we're up here real quick. When you graph it, make sure you graph it and know how, where the intercepts are, how to find that, and then also how to determine where that asymptote is on that graph. I think we're good to go on that. Am I right? All right, we're good? All right, fantastic. Again, those of you who are needing some more help on that exponential compound interest stuff, come in on any morning. We could touch base on that. Other than that, have a great day, and we'll see y'all later. Bye.